Magic. Welcome back, 4.5 through 4.8 review with the lab crew. Back with another episode. Can't wait to get right into this juicy content.
Sounds very enthused. Have you ever seen Cyber Chase?
No.
You remind me of one of the characters, but I don't really.
Cyber Chase?
Like your hair. I don't really know. Yeah. Doesn't he remind you of someone from it? I don't know.
I'm not.
I like your hair. I like your
You see me? I think I'm the first time that isn't one.
All right, so let's do problem 4B here.
Thank you.
4B. That's what we're doing here.
We're not watching Cyber Chase. Wink, wink.
All right, so what kind of function is 4B? It's polynomial, right? So first thing you should do is think about what type of function it is. Like if I unhide 4A, I say, okay, well that's rational. You should generally know what the function should look like. You know, not specifically, but generally should know what it looks like. Okay, well now since we've got a, where did it go? There it is. So since we've got an idea of what we think it's going to look like, it's a polynomial. We know that it's odd positive, up on the right, down on the left, right? So we should generally know what it's going to look like, but we have to identify all of the different pieces. Now, is there any restriction on the domain in a polynomial? No. So the domain is all real numbers. It will go on forever left and right, which makes sense because it will continue up and to the right, down and to the left. Let's talk about our intercepts. Let's ask our y-intercept real quick. Is there a c value? Not a c value, but is there a value on the end? Like a +5 sitting on the end? Is there a constant term? No. We could say a +0. So we know the y-intercept is going to be 0, 0, which we'll also see with the x-intercept as well. But let's find the x-intercept. This is the y-intercept. Let's find the x-intercept. Here's the work for the x-intercept. We say x to the third plus 2x squared minus 8x equals 0. And we factor that down. Pull out the x. We get an x squared plus 2x minus 8. So that means, look, that's an easy type. We pulled out our GCF. Now it's an easy type. And now we've got an, oops, I don't need another parenthesis. An x minus 4, or sorry, excuse me, x plus 4. X minus 2. Yeah. It's so nice. I've had this up here for like 3 days now. I don't want to erase. So nice. So we've got x equals 0, x equals -4, and x equals +2. X equals 0 means we got our 0, 0 back again. X equals -4 means it's going to cross at -4, comma 0. And x equals 2 means it's going to cross at 2, comma 0. So those are my 3 x-intercepts, which is great. If it's an x to the third, fundamental rule of algebra says that the degree should match how many zeros there are. So I've got 3 zeros and x to the third power. All right, let's check for some symmetry. Remember, symmetry is plugging in negative x. So negative x to the third plus 2 times negative x squared minus 8 times negative x. And let's see what we get. Well, this would be a negative x to the third plus 2x squared plus 8x. Is there any symmetry? No, there's no symmetry. Okay. Remember, for there to be an even symmetry, negative x should plug in and completely cancel out all the negatives and turn back into f of x. And for an odd symmetry, negative x should equal negative f of x. Like it should have been a negative x to the third minus 2x squared plus 8x. And that didn't happen. All right, so there's no symmetry. Let's check for any asymptotes. Well, does a polynomial function have asymptotes? No. Okay, that's easy. Intervals of increase and decrease. What do I have to find now for intervals of increase and decrease? The derivative. So it was x to the third plus 2x squared minus 8x. So f prime of x is going to be 3x squared plus 4x minus 8. Right? And the zeros of the derivative are going to be the critical points, the points at where my increase or decrease changes. So let's find the zeros. 3x squared plus 4x minus 8 equals 0. Now, this doesn't look like it factors. Does it factor? Factors a negative 24?
I don't know. No, it doesn't.
Let's just not even check. Who cares? Let's just do the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. It's not the hokey
That
pokey.
is totally not.
16 minus 4 times 3 times negative 8. So my discriminant is 112. So negative 4 plus or minus the square root of 112 all over 6, which is, the square root of 112 is 10.6. So negative 4 plus or minus 10.6 all over 6. I should really get my key. Make sure I'm not butchering this. Just make sure my key's right, please. Okay, good. In the same spot. Negative 4 plus or minus 10.6 all over 6. So I say negative 4 plus 10.6. Oh, come on now. Negative 4 plus 10.6 divided by 6, 1.1. So x is 1.1. That's one critical point. And then we got negative 4 minus 10.6 divided by 6, negative 2.4. Number line, negative 2.4, 1.1. And then we can plug in some values, but spoiler alert, positive, negative, positive. All right, now that means it's going to increase from negative infinity to negative 2.4, but also from 1.1 to infinity. It's going to decrease from negative 2.4 to 1.1. Which means my extreme values should be, so it's increasing then decreasing, it should be a maximum point at negative 2.4, did I say it? Yeah, negative 2.4 comma 16.9. And a minimum at 1.1 comma negative 5.05. And again, to find those values, all you do is just plug it back into the very original problem. Not the derivative, but the very original to figure out where that actually exists at. All right, so we're to F. We've got to do G, which is intervals of concavity and inflection. All right, and for that, we need F double prime, which is, so there's F prime, 3x squared plus 4x minus 8, 6x plus 4. And the inflection points could possibly be at the zeros of this. So subtract the 4, divide by 6, negative 2/3? Yeah.
You're welcome.
No, you're welcome. I thought it was coming in here.
I am coming.
Ah!
I'm not going to escape. What are we doing?
We're doing calculus. We're doing a test review for tomorrow.
What's on the test?
Calculus.
Wow.
Graphing equations.
Well, somebody show me something. I want to see something.
You want to see this graph? Okay, so we're at the point where we figure out concavity. We're at negative 2/3 here. Is it, what's on the left side? Is it negative or positive? Negative. And then positive over here. So that means it's going to be concave downward from negative infinity to negative 2/3, and then concave upward from negative 2/3 to infinity. And now we graph.
I actually understand that.
Oh yeah?
Do you want to grab it?
I know.
Do I want to graph it? Would I be confident?
Did you have to take calculus in college?
No.
No?
No.
Loser.
Yeah.
All right.
I took my favorite math class was stats. I did stats in the MBA.
Figured. Really?
Yeah.
All right, so we've got zeros at 0, -4, and 2.
Oh, I can graph this.
0, -4, so we'll go -1, 2, 3, 4. Come on. -1, 2, 3, 4.
And then positive 2.
And +2. Thank you.
Well, see, come on. You know, it's going to look like.
Oh,
Oh,
really?
go ahead.
Oh, I forgot to identify the inflection point, right? The inflection point is just, we could say -2/3, well, let's just say at -2/3. We never really give the y value. Did I? No, we just said at 2/3. -2/3. So it's somewhere on this left side. All right, now, that's where it's going to change from concave upward to concave downward. So somewhere up here. We know that, how do I know that? Because the maximum value is -2.4, 16.9. So somewhere in here, -1, -2.4. Let's say that's 16.9, right? So let's make this like 5, 10, 15, something like that. Yeah, those are going by 5s. So there's my topping out point, the inflection here up. And I should have put that in a better spot. 1.1 comma negative point. Yeah, that's okay.
Yeah.
Okay.
Yep. Yep.
I'm good.
I believe you.
Did you need me for anything?
Nope.
Coming up there.
I'd like to pick up a little bit of math around.
Don't say anything you wouldn't, you're being recorded right now. So.
No, I like that. Math is my second favorite subject.
What's your first favorite subject?
Gym.
Lunch.
I like math a lot.
That's on record.
I'm getting much more gooder.
More good. All right, any questions on that one? How do we feel on that? In my opinion, the polynomial ones are probably a little bit easier than the other type.
So in your opinion, the polynomial ones are on.
That's not what I said. Not what I said. Yes, sir, Gregor.
Can you scroll back up to E real quick for the first derivative?
Yeah.
Okay, I can see it real quick. Thank you.
Yep.
Until you plug in the combination.
Yeah. Any other questions on this 4B? Go for it.
Number 5.
Yeah. Okay, finding two positive numbers whose product is 50 and their sum is a minimum. Okay, so my two numbers are going to be x and y. I know that the product is going to be 50, and I want to minimize the sum. What's wrong?
I said I feel like you have to think about that every time.
I really do. I was writing the word, like we were doing compound interest, and I was like, but then this looked weird. Interest? I think there's an E in it. That's what my kids, I believe my student. So I'm going to minimize sum. So really kind of F, you could just call it whatever you want. S equals, F equals, whatever. Is there? Oh, what? Whatever to 5. Where did that come from? X plus Y. So I'm going to minimize the sum, knowing that the product is 50. All right, so that means that I can solve this for Y. Y is equal to 50 over X. So that means F is really X plus 50 over X. Now, I want to say something because on the quiz, a lot of people got a common denominator and then took the derivative. You don't need to do that. It's so much easier if you write it as a polynomial. Here's what I mean. Isn't this the same thing as X plus 50 times X to the negative 1? And that's way easier to find the derivative using that rather than some quotient rule once I got common denominators. Because now f prime is going to be equal to 1 plus 50, sorry, 1 minus, because that negative one's going to come down, 1 minus 50 times x to the negative second power. And that's really easy to find the derivative that way. So in other words, that's 1 minus 50 over x squared. And then a lot of people try to find common denominators now. You don't even need to do that. So 0 is equal to 1 minus 50 over x squared, right? So add the 50 over x squared over to the other side, multiply by x squared over to the other side, and now I've got 50 is equal to x squared. I square root 50, turns out to be 7.07. Did I say round to something? 10? So 7.1. Okay. And so that means 50 over 7.1. It should be the same thing because it's the square root, but 50 divided by 7.1 is going to be 7.1? 7.0, whatever. They should both be 7. I would be a little bit lenient there. X is 7 and Y are both 7.1. Yeah, since we got around to there. If you said 7.1 and 7.0, that's fine too. Unrounded, they would be the exact same thing. Good there?
Great.
Claire,
This is another question.
any other questions on this one? Claire, go for it.
Can we do number 2?
Number 2. Yes, we can. You know, I'm kind of using the stuff that we learned from section 4.6, like all the digital stuff. I'm trying to kind of reference all of that within this problem. Because kind of the moral of the story that we got from all of that Desmos work, was that you can tell a lot by the graph of the derivative. You can tell pretty much all of the information by the graph of the derivative, the first derivative. Everything else, is kind of, confirming what you see from the first derivative. So what are the intervals of increase and decrease? Let's go from that. All right, now, if that's the graph of the derivative, everything above the x-axis is increasing, everything below the x-axis is decreasing. So this is increasing at all points above the x-axis. So from everything until 0.205. So negative infinity to 0.205. And then from 0.673 onward. It's decreasing at all points below the x-axis. So from 0.205 to 0.673. Now it asks for the extreme values. There are 2 extreme values. There's a maximum and a minimum. Look, it's increasing and then it switches to decreasing. So what goes from increase to decrease? A maximum point. I know there's a maximum point at, and I don't know what the y value is. I can just say at 0.205. I don't know what the y value is. You can't say that there's a maximum at 0.205 comma 0, because that's not necessarily true. We know the x value will match up, but the y value is just the 0 of the first derivative is just basically where it's occurring on the original function. And we know that there's a minimum point. Okay, well, if it's going from decreasing to increasing, below the x-axis to y, above the x-axis, decreasing to increasing, that's going to be a minimum value at 0.673. Now, state the intervals of concavity. Now, this is kind of a weird one. If it's decreasing on the first derivative, that means the slope of the first derivative is negative, right? The slope of the first derivative is negative. Walk in there. If it's decreasing on the graph of the first derivative, that means it's negative on the graph of the second derivative. If it's increasing on the graph of the first derivative, that means it's positive on the graph of the second derivative. So that means if it's positive here, look, it's increasing all points here, right? That's increasing. That means that's all concave up. So meaning concave up from 0.465, oh, that's, I don't want that, 0.465, to infinity. It's concave down at all points where it's decreasing. So everywhere till right there. So that means all of that is concave downward because it's decreasing. Negative infinity to 0.465. That's what I had to change on the key. That I had flipped those. Concave up to concave down. Which means when it flips from concave up to concave down, that's the inflection point. So the inflection point is at 0.465. Was this used at all? No, that was just extra information. Isn't it cool? I do that when I graph like systems of inequalities. You know, make it overlap and turn into a different color. Okay. Any questions on that one? No. None. Nueve for my Spanish-speaking friends. Oh, this is same one as on a homework. Okay. Get out of there. All right. If 1,200 centimeters squared of material is available to make a box with a square base and an open top, find the largest possible volume of the box. This is very similar to a quiz question. I had just made it a rectangular base where the length was 2 times the width. And then you didn't know the height either. All right, so let's say I've got 1,200 square centimeters of material. I want to maximize the volume. I know that right away. I want to find the max volume. Let's draw it out and see if we could create a good equation from this. Right, the bottom of the box is squared. So if this is the front of the box, let's draw the bottom of the box as x times x. And it's an open-topped box. So we want to make it look like it's open. Now, what we don't know is the height of the box. Let's call that y. So therefore, I know that the volume is equal to x times y, or x squared times y. Everybody follow me there? This is a square base. I can say that it's x times y. Now, let's use this 1,200, because that's got to give me an important piece of information there. Now, the top of the box is open. 1,200 is really the surface area, right? That's the amount of material I need to use to make the box. So if 1,200 is the surface area, I know that that's the bottom of the box. So the area of the bottom is x squared plus all four sides. All four sides. The area of the front is xy. The area of the side is xy. Same thing in the back, same thing on the side. So 4 xy's. This was an issue on the quiz because the left and right side was not the same as the front and back side. So a lot of you tried to say it was 4 times the sides. But all the sides weren't equal because it was a rectangular base. Okay? So if you messed this one up on the quiz, it could have been for that reason. So that's the 1,200. All right. Well, let's solve this for y, shall we? Subtract over the x squared. 4xy is equal to 1,200 minus x squared. And then let's divide by 4x. And I'm going to divide each part by 4x. because I want to simplify it as much as possible. So 1200 divided by 4 is 300 over x. And then I've got an x squared divided by 4x. So I'm going to say x over 4. I could have also said 0.25x if I really wanted to. 1/4 of x. Let's plug that in. So my volume is equal to x squared times 300 over x minus x over 4. And now we multiply in our x squareds. So when I do that here, that's going to give me 300x, because one of them is going to cancel with the denominator. And that's going to give me x to the third minus x to the third divided by 4. Do you follow me there? So now I've got my function. I want to find the biggest volume, find the derivative. So that's going to be 300, v prime is going to be 300 minus, now isn't this just really equivalent to 300x minus 1/4 x to the third? Didn't I just say that we could write 0.25 if we really wanted to? So I'm going to bring it down and multiply, so really 3/4, 3 times 1/4 is 3/4 x to the second. So that's what I want to find the 0 of. Set that equal to 0. Let's add over the 3/4 x squared. So 300 is equal to 3/4 x squared. I want to divide over the 3/4, but really that's like multiplying by the reciprocal 4/3. 400, I believe. Oh, no. That's right. 400. Yeah. 400 is equal to x squared. So I square root it, I get plus or minus 20. But would negative 20 make sense in this situation? No. So the only plausible answer is x equals 20. Which would make y 300 over 20. Oops, that's divided by 20 minus 20 over 4. Well, 20 divided by 4 is 5. So 10. Which makes y 10. Does it say find the dimensions? Find the actual volume. Okay. So the volume is v squared or x squared y. So 20 squared times 10. 4,000. The volume is 4,000. That's the maximum volume. Cubic centimeters. Yeah. Questions about that? All right, what other questions do we have? Yeah. Siete.
That's French.
What? 6 of them?
Yeah. There are 5 of them or whatever. The word problem.
Is there 5 on the review?
Seems like a day.
Yeah,
I wrote them.
Yeah. I mean, this is a 2-day test. You know,
Like first half, they just went right to.
I don't know. Yeah.
I don't know if that was the question I was going to ask or not. I was going to ask, is it divided up in any particular way?
I would say the first half and the second half, day 1, day 2. I went in chronological order of the test. We'll go.
Okay.
Yeah.
I gotcha. Kitchen man.
You smelling what I'm cooking?
Scrolling.
You putting up what? Are you picking up what I'm putting down?
Yeah, that.
All right. So I want to find the point on the line 2x minus 1 closest to the origin. All right. So that means the distance is what it's going to be minimized. Min.
It's always a struggle.
Always a struggle. Minimum. I just min distance. Min dist. Well, the distance formula again is let's use the square root one. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, the nice thing about this is it's going to the origin, which is 0, 0. Makes our life a little easier. So what we're going to do is plug in. We're going to have x minus 0 squared plus y minus 0 squared. I can take away the y1 and the y2 because I plugged 1 point in. So there's only one x and one y. Now, to get it down to have only one variable, I know that y is equivalent to 2x minus 1. So d is equal to the square root of x minus 0 squared plus 2x minus 1 minus 0 squared. And now I can start evaluating. I'm going to get this pesky square root over to the other side. D squared is equal to x squared, x minus 0 squared is x squared, plus, and then 2x minus 1 squared. So let's FOIL that out. X squared plus 4x squared minus 4x plus 1. Outer's a negative 2x, inner's a negative 2x. Negative 1 times negative 1 would be positive 1. So that means I've got d squared is 5x squared minus 4x plus 1, which means now I find the derivative, 10x minus 4, and set that equal to 0. D squared prime, I guess. We want to write it like that. So 10x is equal to 4. So x is equal to 0.4. And then we just have to plug it into y is equal to 2x minus 1. So y is equal to 2 times 0.4 minus 1. So 0.8 minus, well, whatever. 2 times 0.4 minus 1. Negative 0.2. Y is equal to negative 0.2. So 0.4 comma negative 0.2. That's the coordinate. Yes.
Is tomorrow the non-calculator?
Correct, yeah. Just like the quiz was. Yeah. The 4, 5, 4, 6 quiz.
Yeah.
Yeah. Yep. Yeah, I just basically took your two quizzes and kind of smushed them together. And then added on a couple of questions from section 4.8. Yeah. It was a 4, 5, 4, 6 quiz and then 4, 7 quiz. And then we did section 4.8. Okay. And those are the last two questions on there, the use Newton's method. Yep, the 4.8 ones. Yes? Yes.
Like 5 of them? Like 5 4 questions?
No.
Right.
I know, you'd like that, right?
Yeah.
All right. Yeah, Christian. 8. All right. Farmer with a 600-foot of fencing wants to enclose a rectangular area, then divide it into 4 pens. Oh, yeah, this was a quiz question. A lot of people made the wrong diagram. So I tried to caps lock the important piece here that a lot of people missed. A lot of people said, oh, if I want to divide it into 4 pens, I'm going to do it like this. Are both of those lines parallel to one side? No. This one's parallel to this side, and this one's parallel to this side. So that's not a valid diagram. So here's what I have to do. I want to cut it into 4 pens like this, all parallel to one of the sides. Doesn't matter. You could have made this vertically as well. All right. So largest possible area. Max area. All right. Well, if this is, let's make this long side y and the short side x, which means all of these are x as well. Okay, so area is going to be equal to just plain old x times y. Let's use the fact that we've got 600 feet of fencing to use here to give myself a second equation. Let's get 600 is equal to 1, 2, 3, 4, 5 x's and 2 y's. let's subtract over the 5x. And divide by 2. Now, here's the thing. Can I actually divide by 2 to these numbers? Yeah, and a lot of people didn't do that. A lot of people tried to like make it one big fraction or something. Yeah, you don't need to do that. 300 minus 5 divided by 2 is just like 2.5. 2.5x. Yeah.
Why didn't you do 8y? What? Could you do that? That's what I did. I made them like mini ones and then I added them all together.
That's what I did with the journal.
Oh yeah, okay.
What?
Yeah, that works too. I just made the big side as a y.
Okay, it still works.
It still works.
Okay.
Yeah. Yeah. So we got 300 minus 2.5x is equal to y. So I'm going to plug that into my area formula. Area is equal to x times 300 minus 2.5x. So area is equal to 300x minus 2.5x squared. And now we find the derivative. A prime is 300 minus 5x. So finding the 0 of that, 300 is 5x. So it comes out to be 60. Is that right? 60 is equal to x? Just double checking. Hold on. Hold, please. Was this 8? Yep, 60 is equal to x. And then I plug that back in to find y. 300 minus 2.5 times 60. 150. So y equals 150. Oh, this symbol?
Yeah.
And that's a 150, yeah. And then is that it? No, I want the area, right? I want the area. So the area is equal to 60 times 150, or in other words, 9,000 square feet.
Start your letters from the bottom.
Huh? I start from the
What do
top.
you just do when you do your FC? Start from the bottom.
You start from the top on an F?
You always start your letters from the top.
That's not something I've ever heard.
Yeah, I will.
You start your.
I don't have any letters.
Yeah. Our moms are kind of good. Our moms are good. So
What about like an N?
you go top, down, up.
What?
Yeah.
My mom teaches
This?
fundamental
Like-
writing.
This?
Yeah.
Yeah.
That's too much.
What do you do?
I mean, it's more reasonable to start at the bottom.
Same thing with an M. You start from the top on an M?
Always.
Yeah. All the time.
That's weird.
No. You just what do you do? No, I just start from top. I start from the top. You go.
What?
Yeah, so-
Yeah.
You do an extra?
Yeah.
Yes.
No.
I can add.
Imagine the amount of times that you're going to write the capital letter M in your life.
Why say
Compile all of those.
less words each?
Calculate the amount of time it takes you to make that extra line. That's the time wasted in your life that you will never get
You
back.
always start your letters from
You'll never get back.
Always start from
Why don't we-
my M.
Why don't we calculate that?
What?
Do an F.
An S? I start from the top.
An F.
So like.
An F. No.
That feels so.
I do that too.
Wait, I do.
No,
No.
I'm pretty sure it's yeah. Yeah,
All right.
Claire starts from the top. Got another one.
Are there any other math questions that we'd like to go over?
It's just an observation.
I leaned into it. I just. Hey, efficiency.
Oh.
Efficiency over. All right, here we go. I'm gonna turn off the video here. Great video.
Keep writing.
I don't know.